Hi, let's solve this question. This question is taken from SPM 2021 Paper 2 Section B and it is from your Form 4 at Math Chapter 6 Linear Log. Now let's look at this question. Table 1 shows the value of two variables x and y obtained from an experiment. The variables x and y are related by the equation of this where h and k are constant. So for the first part, we want to plot xy against x. It means that the vertical axis is xy and the horizontal axis is x. Using a scale of 2 cm to 1 unit on the x-axis, it means that 1, 2, 3, 4, 5 and so on. And 2 cm to 0.5 units on the xy axis, 0.5, 1, 1.5, 2, 2.5 and so on. Okay, after plotting the graph, we need to draw the line of best fit. So from here, we know that we need the value of xy and x, right? So the value of x, we already given the value of x, so we don't have to find the value of x, but we don't have xy. So we need to calculate ourselves what's the value of xy. How do I get xy? It's very easy. You take this one times this times this. Okay, so this is all the value of xy. 1 times 3.25 you get this, 2 times 1.28 you get this, and so on. Okay, so here is my suggestion. Let's say you notice that your graph is going downward like this. It is good for you to leave some space here. Why do I say so? Let's say maybe sometime we plot until here, right? But you know, right, when we draw the line of best fit, we always need to draw until the vertical axis. So if you do not leave some space here, you might facing problem later. You try to connect but not enough space for you to get the reading, because we always need the reading to help us to solve the question. We always need the y-intercept here to help us to get the answer. So it's good for you to leave some space here. So for example, if the graph is like this, right? So I would suggest you to leave some space here because, as I told just now, let's say if you plot the graph like this, after that you connect them together, you notice that you don't have enough space here. So you need to redraw the graph. It's actually take time, right? Okay, so it's better that we leave some space. Okay, now let's look at this graph. Same thing here. I do leave some space here so that you look at here, the maximum only 3.25. So if you only draw until 3.5, now you're not able to get this one, right? So I would suggest you leave some space here. Okay, so how do I get all this, how to plot all this graph? I think it should be no problem, right? Okay, so first I will write this. This is for your own reference. You want to do so or not, it's up to you. So y is x is equal to 0.1. 2 units here is 1, right? Oh, sorry, not 2 units, sorry. 2 centimeter, 1 unit. So we have 10 small grid. So I'm going to take 1 divided by 10, therefore I get 0.1. So here, 2 centimeter, 0.5. So here, 10 small grid. I take 0.5 divided by 10, I will get 0.05. So for example, let's say I want to plot this one. First, I look at 4, then I know it's somewhere around here, right? Somewhere around here. And then 1. How do I get 1? So you can read it here, or you can take out your calculator. Take out your calculator. Let me show you. Okay. You key in 1. Divided by 0.05, then you will get 20, then 20. Okay, so for example, how about 0.25 0.25 divided by 0.05, you get 5. So calculate, this is 5, right? 5 small grid. So how about this one? Negative 0.54, you just key in 0.54 and then divided by 0.05, you will get 10.8 small grid. But it's very hard for us to get 10.8 by our naked eye. So just roughly 10, very close to the number 11 grids. But we plot before the 11 grid. So let me show you, make it larger. This is 10, right? So 10.8, just roughly only, because it's very hard for us to get 10.8 accurately by just by our naked eye. Okay, so this is the way how do we plot all the point. After plotting all the point, you just use a long ruler to connect this all the point together. So we try to connect as many points as we can, and if the point that we are not able to connect them, we try to distribute them evenly. Okay, and remember, every time you have to draw until the vertical axis. Okay, so this is the answer for part A. So let's say you want to use your calculator to check the answer. You can do it this way. Take out your calculator, then press menu, choose 6, statistic, number 2. So just key in all this value, 1, 2, 3, 4, 5, and 6. Now for xy, so this is 3.25, the first one, 3.25, 2.56, 1.74, and 1.0. You can just key in 1, 0.25, and negative 0.54. Make sure all the value key in correctly, and then press option, choose number 4. Now can you see it? So this is our y-intercept, which is 4. Okay, this is 4 point something, but we cannot get 4.04 at this. We cannot get as accurate as the calculator, but it should be no problem. It's 4. And then the gradient here, according to the calculator, the answer is negative 0.76. But later on, when you use a graph to calculate, maybe slightly different from this one. Slightly different is okay. If different a lot, then you might need to recheck again. Maybe you plot it wrongly or draw the line of best fit incorrectly. Okay, now let's proceed to the part B. Okay, this is B part 1. We want to find the value of x when y squared is equal to 4 over x squared. Okay, this is a little bit tricky. So you need to do some calculation over here. So y squared is equal to 4 over x squared, but we don't have x squared, we don't have y squared. Is it okay? I bring the x squared over here, it becomes x squared y squared equal to 4, right? So here I can actually change them, become like this. And xy, we do have xy, is square root of 4. So some students might be thinking, teacher, why not we add a plus and minus? So the answer will be plus and minus 2. But I think the question only wants you to take the positive one, because we cannot get the xy negative 2, not able to get it from our graph. So I will just take the positive one. Okay, xy is equal to 2. It means that this happened, it means xy equal to 2, right? So when xy is equal to 2, what is the value of x? So it means that our answer is over here. So look for 2, draw dotted line until you're touching the graph that the line of best fit, then go down, making a small arrow here, and read the reading here. So according to my graph is 2.7. So the x is equal to 2.7. So this is the answer for first part. Okay, now let's look at part 2. We want to write this in linear form. We want to reduce it in linear form. Hence, find the value of h and k. Okay, y plus square root of h is equal to k squared over x. So we want to reduce this to this form, y equal to mx plus c. So how to deduce this? It depends on the what graph the question asks you to draw. So the question asks you to draw xy against x, right? So from here, you know this, you have to change it until you see xy. So this one is x. So what I'm going to do here is I multiply the whole equation by x. Why do I do so? Because I want to see xy. So multiply the whole equation by xy. Oh, sorry, not xy. I just multiply the whole equation by x. Okay, now I forget xy over here, and this is x square root of h, and this is k squared. Now I got xy. So what I'm going to do next, I'm going to move this go to another side. So xy is equal to negative x times square root of h plus k squared. So I'm going to rearrange all the terms here nicely in y in the form of y equal to mx plus c, so that easier for us to compare later. So this one, I notice that the graph is negative gradient, right? So I'm going to do it this way. Okay, so this is y equal to mx plus c. Let's find k squared first. So this k squared c, it means that the xy axis, the intercept for xy axis. So according to our graph is 4. K squared is equal to 4. So k is equal to square root of 4. But the given answer is only this, k is equal to. But in my opinion, I think it can be negative as well, right? K squared equal to 4. So if you calculate the value of k, we should be able to get two answers, which is positive 2 or negative 2. But the given answer is only positive 2. Okay, but anyway, this is the way how do we get the value for k. So now, by comparison, you know that negative square root of h is equal to the gradient. How do I get the gradient? So it's up to you. Some students like to draw a triangle like this and then calculate the vertical distance and horizontal distance. But if you are using this method, you need to be more careful. You need to add a negative. Let's say, for example, I just simply give you a value. Let's say this is A, this is B. So the gradient is not A over B, but negative A over B. Okay, so if you worry that sometimes you might forget to add the negative sign, so you can just choose two coordinates and use them to help to get the gradient. Okay, so I think I will choose this one, 0, 4, and how about another one, this 4, 1. Okay, don't choose this one because this one I think the line do not pass through the point here. Okay, let's use this two. Now 4 minus 1, remember y on the top, 4 minus 1, and then 0 minus 4, 0 minus 4. Okay, so this is 3, negative 3 over 4. Okay, you can cancel out the negative sign. So h is equal to 3 over 4 square, because this is square root, right? So we square both sides so that the square root, the sign of the square root will disappear. So we square both sides so that we will get this one. So okay, so this one, 3 square is equal to 9 and 4 square is equal to 16. So this is the value of h. That's all for this video. See you in the next video. Bye bye.